This pre-cal lesson is about polar coordinates. Previously, we've talked mostly about rectangular coordinates. That's been most of your math life. More recently here in pre-cal, we talked about parametric coordinates, which involve t, x, and y, so 3 different variables. And today we're talking about polar coordinates, which kind of relates to that unit circle idea. It kind of relates to taking things off of an x and y grid and more to a circular field. This is used for things like direction, particularly in flight is where you might have seen something like this, or if you're talking about ship direction and some different things that go like that. Let's start by defining the origin as a fixed point. So instead of thinking of the origin as 0, 0, it's a fixed point 0, and it's called a pole. Okay, so that's called your pole. After we define the word origin, let's define what a polar coordinate is, or how we describe it. In rectangular coordinates, we've always described them as an x and y point. For polar coordinates, it's an r theta. So that's how this is starting to become different. The r represents the radius, the distance from the pole. Again, the pole is the origin, so a distance from the pole out. And the theta tells me the direction in which that ray is oriented. So r is a directed distance from 0 to p, and you'll want to think of that as the radius. And then your theta is a directed angle, and to get that we're going to use the values from the unit circle, which you memorized a while back, so that should still be pretty fresh in your mind, or it needs to be anyways. If I start here at 0, and I start at 0 degrees, as far as thinking my unit circle, how that would go, then I could take my angle out here. This distance is my r, this distance here, and the direction is my theta. And so that would take me to a point P. Okay, that's how I'm going to use these things when I measure. On your paper, you've got 3 circles, so we're going to start with number 1, and I want you to find 3 negative pi over 3 as your point. Okay, we're going to start here. We're going to start with at our origin, or our pole, and we're going to count out in the direction of 3, because that's our radius. So 3 would be like 1, 2, 3, or 1, 2, 3. Now, we also want to think about where my angle is. So if I say I'm starting here at 0, and I want negative pi over 3. You should remember that pi over 3 is somewhere about here, right? This is pi over 3. And let's see, there's 1, 2, 3, 4, 5, 6 in this first quadrant. So this would be 2 pi over 6, 3 pi over 6, which would be, pi over, okay, let me think about this again. These are divided into 12, so let me restart. Pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12. So this would be pi over 3 when reduced. To get negative pi over 3, I would go back in the direction of 4. 1, 2, 3, 4. This is negative pi over 3. And if I go out 1, 2, 3, then this is my angle. Again, you'll need to figure out how many this is going around. I'm giving you these to start with, and they're going by 12, so you'll want to reduce, meaning this first one would be your pi over 6, this would be your pi over 3, and halfway in between would be your pi over 4. That would be what you'd be more familiar with from your unit circle that we previously talked about. Now I want you to give me 2 coterminal points, or 2 other ways to describe this one that we've just graphed. Now, one thing I could do is, this one is in the negative direction, so I could start with 3 again, and I could say, okay, well, what is this in the positive? So if I say pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and this would then be 5 pi over 3. And that's a coterminal angle, so same direction, just saying the positive, and then 3. And then I want to show you what we would do to get a negative angle. So this is another tool that you could use. And that's to do a negative radius, okay? So to do a negative radius, that causes me to reflect over the x-axis. So to do that, it would be as if I was going to 2 pi over 3. Let me mark that here because this is opposite, right? This is kind of flanked at an opposite 180 degrees. So I'm going to go to 2 pi over 3. And if I go to 2 pi over 3, 1 pi, 2 pi over 3, and I go out 1, 2, 3, if it's negative, then I reflect it right here, and that makes it at the same exact point. So that's another way that you could get a coterminal angle or a coterminal point, another way to describe this in polar coordinates, to go to the opposite place on the unit circle and then flip the sign of your radius. Let's look at some more examples of how to do this. That's all we're focused on today. Example 2 is 2 comma pi over 6. So let's move our paper so we can see that. Pi over 6, this is pi over 12. 2 pi over 12, which is pi over 6. So I'm going to go ahead and label that, pi over 6. And then I'm going out 2 from the center, so 1, 2 here. And I can go ahead and draw to that point. And the point is the part that's important here. And then I want to label it 2 other ways. So we're starting with pi over 6. Let's go ahead and get another one that's coterminal. So let's do 2, and let's go around once. So if I go around once, that would be 13 pi over 6, right? Because I would do pi over 6, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi would be all the way around, 7, 8, 9, 10, 11, 12, 13 pi over 6 would be right here. And as you can tell, maybe this is kind of weirding you out as much as it is me. These extra lines are kind of funky. So maybe if I was you, I would go ahead and draw these, kind of thicken the ones that would be on our normal unit circle so it's just a little easier for you to count around. That's what I'm going to do. Just kind of model that for you so that you're not getting confused like I am. And that way we can count around what we're used to looking at. Kind of don't worry about these little ones that are in between that we haven't previously used. Now let's do one that has a negative radius. So I'm going to do negative 2. If I did that, I would need this angle here, 1, 2. And so if I'm talking about this angle, this would be pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi, 6 pi, 7 pi over 6 would be the one that causes that to reflect back over the other side. So that would be 2 that are coterminal. Let's do one more example, 3. And that is 2 and negative pi over 6. Okay, let's start by making our markings. And if I'm doing negative pi over 6, I'm going right here. That's negative pi over 6. And if I'm doing 2, that would be 1, 2 here. And so that's my point. If I want to get 2 more, let's do 2, and let's go around the circle once. So pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi over 6 would be one that is the same point. And another way to describe that would be in the negative form. So I'm going to do negative 2, and then we want to find the one that is opposite. So that would be this one here, and that would be pi over 6, 2 pi, 3 pi, 4 pi, and 5 pi over 6. And that's how I'm going to do that. That's what we're practicing today on your assignment. And that assignment is A12, and it's page 783, numbers 1 to 8. Good luck, and let me know if you have questions.